everyone. Today we are going to learn about how to perform operations with complex numbers. Now, complex numbers is brand new information. You've never learned, most people have never learned about complex numbers before. What the complex numbers are is taking everything that we know about real numbers to a whole nother level. But before we get started with that, I want you to go ahead and pause the video and evaluate each of these powers. The first one is -5 squared. The second one is -3 squared. Letter C is -2 to the third power. And finally, letter D is -5 to the third power. Please watch your signs as well as look for which ones have parentheses and which ones do not have parentheses. So be careful with this warm-up because you'll end up with different answers. And when you finish with the warm-up, go ahead and restart the video and then we'll get started with our lesson for today. All right, let's see how well you did. So for letter A, we have -5 squared. Notice that the 2 is on the outside of the parentheses, so that means that we're talking about -5 times itself twice. And -5 times -5 is +25. For letter B, -3 squared really means -1 times 3 squared. And that's because the square is closer to the number 3. So unless you see parentheses, the way that we interpret this problem is exactly the way I have expanded it. -1 times 3 squared. We all know that 3 squared is 9, so this is really equivalent to -1 times 9, which is -9. Next, we have -2 to the third power, which notice that the 3 is on the outside of the parentheses, which means that we're going to be multiplying -2 times itself 3 times. -2 times -2 is +2. I'm sorry, +4. And +4 times -2 is -8. So our answer ended up being negative. And finally, we have -5 to the third power, which once again, we view that as -1 times 5 to the third power. So this is going to be 5 to the third power, which is 5 times 5 times 5, which is 125. And -1 times 125 is equal to -125. So hopefully you did pretty well with these problems. Like I said, you have to be very careful whenever it comes to your negatives, as well as where is the exponent located with respect to the number. Is it next to the parentheses or is it next to the actual value? So that kind of information is going to be something that will help you for this next topic. So like I said to you before, complex numbers is a brand new number system. And what we have here is a situation in which mathematicians have always wanted to be able to solve every single type of problem out there. But there are some problems where we just don't have a number as an answer. Like, for example, x squared equals -1 has no real solution because we know that you can't take a square root of a negative number and end up with a real answer. So what mathematicians decided to do is they decided to create their own set of numbers. And they called it, instead of real numbers, they called it imaginary numbers. And imaginary numbers and real numbers, when put together, create the complex number system. So your learning objectives for today's lesson is to be able to say that you can solve quadratic equations even when there are no real roots. Your answers might end up being imaginary numbers, which means that your x-intercepts would not technically exist, yet you would come up with a solution or an answer to our problem. Next, I want you to be able to say, I can use imaginary numbers to simplify radical expressions. So we're going to be simplifying radical expressions where we're going to be taking the square root of a negative number. Next, I want you to be able to say that I can add, subtract, multiply, and divide divide complex numbers. So we're going to be working with adding, subtracting, and multiplying the numbers first. And then when we divide complex numbers, we're going to be working with a conjugate that's very similar to the conjugate we used in our last lesson. That's because of the fact that the imaginary number is going to be related to square roots, and I'm going to talk about that in just a second. So please know that not all quadratic equations have real number solutions. We know that because we've learned that if you end up with an x squared is equal to a negative number, if we were to take the square root of both sides, we would know that x is equal to no real solution, so no real solution. And that's what we've learned in Algebra 1. So now what we're going to do is we're going to take this to another level and actually come up with a solution. So what I have here is x squared equals negative 1 has no real solutions, and that's because the square root of any real number x is never a negative number. We know that we can only take square roots of positive numbers. So like I said, to overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. So they literally call it out for what it is. An imaginary number is called the letter I. And I, the imaginary unit I, is defined as I equals the square root of negative 1. So that means that I squared equals negative 1. Let's really look at this. So if I is equal to the number, the square root of negative 1, which we know that we can't take the square root of a negative number. So this number right here is considered I. If we were to square I, we would be squaring both sides. I would be squared, and the square root of negative 1 would also be squared. And we know that the square of a square root cancel each other out, leaving us with the answer of negative 1. This information is something I need you guys to please make sure that you study and pay attention to. You need to know that I is equal to the square root of 1 and I squared is equal to negative 1. So whenever you see an I squared, we're going to replace that letter with the number negative 1. There exist some properties of the square root of a negative number. The first property is that if you're taking the square root of a negative number, we can split, like the square root of a negative 3, we can split this up into two parts. This is really the square root of negative 1 times 3. So negative 3, I can rewrite that as the square root of negative 1 times 3. Then I can even split that apart even more to make that the square root of negative 1 times the square root of 3. The square root of negative 1, we would call that I. So our answer would be I square roots of 3, and that's how we would rewrite this expression. Next, the next property is that if you have I times the square root of r squared, that equals negative r. So what I mean by that is this. Let's say that we have I times the square root of r squared. This means that we have the main operation is multiplication, so I have I squared times the square root of r squared. Well, I squared, remember I said anytime you see I squared, that's equal to negative 1. So this is like negative 1 times the square eliminates the square root, leaving you with r. Negative 1 times r is negative r. And so that's how that ends up working out. So if you have I times the square root of 3 squared, each part would be raised to the second power. So we would have I squared times 3, which is like negative 1 times 3, which is negative 3. So we can now, what this all means is that we can now solve quadratic equations we couldn't solve in Algebra 1. So this is an example of how we're taking everything you learned in Algebra 1 to a whole nother level. So this time around, I'm going to give you equations where before we said no real solution, now we're going to have a solution. And I want you to leave your answer in simplified radical form. So the first thing I'm going to do for example number 1 is we're going to take the square root of, get rid of the square by taking the square root of both sides. By doing that, we now have x is equal to plus or minus the square root of negative 13. So negative 13, well, that's equivalent to plus or minus negative 1 times 13. which the square root of -1, we know that that is equal to I. So our answer is going to be plus or minus I times the square root of 13. And that right there is our answer. Remember that we always have plus or minus in our solution whenever you are solving an equation working with square roots. Let's look at example number 2. Example number 2, we want to get the squared term alone, so I'm going to subtract 18 from both sides, and I end up with 2x squared is equal to -90. From here, I'm going to divide both sides by 2, and I end up with x squared is equal to -45. From here, I'm going to take the square root of both sides, and I end up with x is equal to plus or minus, well, 45. This really means -1 times 45. So that -1 right here is going to become I. So now what I'm going to do is I'm going to break down 45. And I'm going to think to myself, what perfect square number can go into 45? And I know that 9 times 5 is 45. So this is going to be the square root of 9 times 5. And I know that the square root of 9 is 3. So this is I times 3 times the square root of 5. So the way that we really write it is we always put our real part first, then imaginary, then our root. So our answer is going to be 3i times the square root of 5. So like I said, it's going to be real, imaginary, then your root. So maybe I should write that down. Whenever we write out these numbers, it's going to be real, then imaginary, then your root. So that's the order in which we always write our numbers. So our answer is going to be plus or minus 3i times the square root of 5. And that is our answer. Let's look at example number 3. For example number 3, I'm going to subtract 33 on both sides. I end up with 5x squared is equal to -30. I'm going to divide both sides by 5, and I end up with x squared is equal to -6. I'm going to take the square root of both sides, and I end up with x is equal to plus or minus. Well, since 6 is not anything that we can break down, I just know that the square root of -6 is -1 times 6. And I know that the square root of -1 is I, so my answer is plus or minus I square roots of 6. Now please know that any complex number can be written in the form of A plus B times I, and that is where A is considered the real part and B times I is called the imaginary part. So there's always going to be a real part and an imaginary part in any complex number. Now please know that any number you can think of, both real and imaginary, is considered complex. Now, every single number will be considered complex. And because this is a number, because we're talking about numbers, we can add, subtract, multiply, and divide numbers. So that's exactly what we're going to do on the next page. We're going to add, subtract, multiply, and divide. You can treat I like it's a variable, but do you know that if you end up anywhere in your problem with an I squared, we automatically replace it with the number -1. So here we go. I'm adding 2 different complex numbers. So pretending as if I is a variable, we would simply drop the parentheses and combine like terms. So CLT means combine like terms. So this is going to be 12 minus 11i plus -8 plus 3i. All of my real parts are going to be combined, so I'm going to take 12 and subtract 8. That's going to be equal to 4. And I'm going to combine my imaginary parts. -11 plus 3, that is going to be -8i. And that's simply your answer. You combine your real parts, you combine your imaginary parts, but please make sure that real comes before imaginary. If you have it the other way, you will receive -1/2 on your test, and you don't want that to happen. So it's always real before imaginary. For number 5, you're going to have to get rid of the parentheses by distributing the negative to each term, just like we did at the very beginning of this class in our very first unit. So I'm going to write 15 minus 9i minus 24 plus 9i. I'm going to combine my like terms, and we have 15 minus 24, and 15 minus 24 is negative 9. And then we have negative 9i plus 9i. Well, 9 minus 9, that is 0, so those cancel out, and our answer is negative 9. Next, I'm going to simplify this expression by getting rid of my parentheses and distributing that negative to each term. So we have 35 minus 13 minus 4i plus I. Combining my real parts first, I'm going to combine 35 minus 13. That is equal to 22. Then I'm going to combine my imaginary parts. Negative 4i plus I is negative 3i. So my answer is 22 minus 3i, and that is your answer. So not only can we add complex numbers and subtract complex numbers, we can also multiply complex numbers. Now please remember, like I said to you before, whenever you see an I squared in the problem, you turn it into a negative 1, and then you can continue combining your like terms just like you normally would. So please be careful. Some problems will have a plus sign between the parentheses, some of them don't. If you see a plus sign, you add. If you see no plus sign, you multiply. I know that sounds very basic, but for some reason kids mess up on that, and I just don't want that kid to be you. So here we go. I'm going to distribute just like we normally have done in the past, and I'm going to end up with negative 40i. And then negative 5 times negative 9 is positive 45, and I times I is I squared. Oh, we have an I squared. That means that we're going to have to change that I squared to being a negative 1. So that's going to be negative 40i plus 45 times negative 1. So I'm going to simplify this just like I normally would, making sure the real part goes first. Here's my real part. 45 times negative 1 is negative 45. And then I'm going to write minus 40i, and that is your answer. There's nothing more for you to do. Looking at number 8, we have essentially a binomial, two binomials that we're multiplying together. So in this case, we're going to FOIL. So I'm going to multiply negative 8 times 4, that's negative 32. Negative 8 times negative 7i, that's plus 56i. 2i times 4, which is plus 8i. And then 2i times negative 7i, that's going to be minus 14i squared. Oh, we have an I squared. We need to replace that I squared with the number negative 1. So I'm going to write negative 32, and I'm going to combine my like terms in the middle to make that plus 64i. And that's going to be minus 14 times negative 1. Now, negative 14 times negative 1 is positive 14. So this is negative 32 plus 64i plus 14. So now what I'm going to do is combine my real parts of negative 32 plus 14, and that equals negative 18 plus 64i, and that is my answer. So for number 9, we're going to do the exact same thing. We're going to FOIL, because we essentially have two binomials that we're multiplying together. So I'm going to multiply 2 times negative 4 to get negative 8, 2 times negative 5 to get negative 10i, I times negative 4 to get minus 4i, and I times negative 5i to get minus 5i squared. Oh my goodness, we have another I squared. We're going to change that I squared to a negative 1 and combine our like terms. So I have negative 8 minus 14i minus 5 times negative 1. Negative 5 times negative 1 is positive 5, so that's negative 8 minus 14i plus 5. Now from here, I'm going to combine my real parts, and so that's going to be negative 3 minus 14i, because remember, we always go real before imaginary. So now we have added, we've subtracted, and now we've multiplied complex numbers. Hopefully so far it's been pretty easy for you, or at least not that bad. So now what we're going to do is we're going to divide complex numbers. And if you look ahead, we have i's in our denominator. Now remember that I represents a square root. I represents the square root of -1. So we really have a root in our bottom. So we have a root in the bottom. And because we have a root in our bottom, we're going to have to work with the conjugate. Just like we did before, the conjugate is going to be the exact same thing as the last lesson. So when we're dividing complex numbers, you should multiply both the numerator and the denominator by the conjugate. The conjugate of the denominator. So the conjugate, for example, if you have a plus, we had before the square root of b, the conjugate was a minus the square root of b, so now it's going to be a minus b times I. So the conjugate is going to be the exact same structure. The only difference is that one's going to have a plus and the other is going to have a minus. Just 1 second, guys. Sorry about that. So let me go ahead and show you how this is done. Example number 10. We have an I in our denominator. We have a root in our bottom, and we have to get rid of it. Okay, come on, focus. Where are we at? Oh, how annoying. Hold on, you guys. Here we go. Thank you for your patience. Here we go. So our conjugate, we have to get rid of this square root of -1 in our denominator. So our conjugate is going to be 5 plus I, and that's what I'm going to multiply both the numerator and the denominator by. 5 plus I. So whenever you see a plus or minus, we're going to be putting it into parentheses, and we can still use the shortcut that we discovered in our last lesson. Now remember that the shortcut is going to be a difference of squares, so we're going to be, and this the shortcut is only for the denominator, which is going to be an a squared minus b squared. So what I mean by that is this. In the numerator, we're going to FOIL. So we'll have 15 plus 3i, and then we'll have plus 20i, and then 4i times I is plus 4i squared. Notice we have a 4i squared. We're going to have to change that I squared to a -1 at some point. In my denominator, this is considered a difference of two squares. So the shortcut is to take 5 and square it minus I and square that. That's going to be our shortcut, where you square each part and then subtract them. It's called a difference of two squares, DOTS. A dots situation. Now we're going to simplify, and anything that we can combine, we're going to combine. Anytime we see an I squared, we're going to change that to a -1. So I have 15 plus 23i. I just combined my like terms right here. And then I have plus 4 times -1. All over, 5 squared is 25, and this is going to be minus I squared, which is -1. So now we have 15 plus 23i, and 4 times -1 is -4, so I'm going to write -4. This is all over 25. We have a negative times a negative, so a negative times a negative makes a positive, so that's going to be 25 plus 1. Combining my like terms, we have 15 minus 4, which is 11. So 11 plus 23i is in my numerator, and 25 plus 1 is 26. This is our denominator, and that is our answer. So once again, what I did here is I FOILed in the numerator because I have a plus sign and I have a plus or minus sign, so I'm going to FOIL just like I did up here. I FOILed. And anytime I saw an I squared, I changed that to a -1. And then in my denominator, I used the trick. You're more than welcome to FOIL. Please know that. In the denominator, you're more than welcome to FOIL. However, I strongly recommend that you try to learn your shortcuts, which means that we're going to take our first term and square it, then minus our second term and square it. That's what we use with our shortcut. Here is number 11 and our last example of this video. So for number 11, I'm going to multiply both the numerator and the denominator by the conjugate. And our conjugate is going to be 1 plus 4i. It's going to be the opposite sign of our denominator. So this is 1 plus 4i. And I'm going to put anything with an addition or subtraction sign into parentheses. Please note that in the bottom, we can use that a squared minus b squared trick. That's called dots. So we are allowed to do that. And in our numerator, we're going to FOIL. Please note that you can FOIL for both, but I strongly recommend using that shortcut. So I'm going to multiply 7 times 1 to get 7, 7 times 4i to get plus 28i, 5i times 1 to get plus 5i, and 5 times 4 to get plus 20. I times I is I squared. We have an I squared. We're going to have to change that to a -1 at some point in our process. And down below, because we're dealing with the difference of two squares, we're going to take our first term and square it, minus our second term, which is 4i, and we're going to square that. Notice I used parentheses. That might be something to consider, because we're squaring the entire term, so just be careful there. So this is 7, and we have 28 plus 5, which is plus 33i. And then we have plus 20, and I'm going to change I squared to -1. This is all over, excuse me, you guys. This is all over. We have 1 squared, which is 1, minus 4 squared, which is 16, times -1. So I have 7 plus 33i, and then 20 times -1 is minus 20. All over. We now have 16 times -1. So this is technically plus -16. So we have a -16 times a -1, which is a positive 16. So that's 1 plus 16. 7 minus 20 is -13. So we have -13 plus 33i all over 17, and that is your answer. And the end of today's video. So today's video was all about adding, subtracting, multiplying, and dividing complex numbers. And hopefully complex numbers are not as complex or as scary as they sound. But if you have any questions over anything, as always, please feel free to email me. And I will talk to you next time.